Okay, so now what we're going to do is we're going to be working with the composition of two functions. So basically it's asking us to evaluate the composition of our trigonometric functions, obviously without a calculator. And remember just composition of functions, just kind of, quick review here. We dealt with, if I said like f of x equals, x squared and g of x equals, 3x minus 1. If I wanted to apply the composition, basically plugging one function into the other, then that would look something like 3x squared minus 1, where you take the f of x function and plug it into the other one. So that's basically what we have. We have a function, and we have a regular trigonometric function, and we have an inverse function, and we're plugging one into the other. Now, again, when we look at the value of evaluate, we're trying to find the value of this composition. So what we're going to do is, just like if we wanted to find the value of this composition, what I would do if I said, what is then f of 1? Of this composition? Well, what we're going to do here is we're going to work from the inside out, right? You're going to square the 1, multiply by 3, and then subtract the 1. So you work from the inside out when you're evaluating the composition of two functions. So what you can see here is, in this first example, we have the sine inverse of negative square root of 3 over 2. So what we're going to do is evaluate that, just like example 1. You can see there's a lot more of these examples, right? Stop. So that's what we're going to do. We're going to first just focus on the middle, and then we'll work from the outside out. So let's just do this just like example number 1. But we're going to have to start doing this a little bit quicker because obviously we have 2 more operations now to go. So the sine inverse of negative square root of 3, and so I'm going to do a little bit of work in my head, and hopefully I don't make any mistakes. But obviously when you're doing this problem over and over and over again, you start to mix things up. So I kind of want to have something. Well, let's kind of work on. Maybe I'll do a little unit circle here, just at least the first quadrant. No, we have the first quadrant. I think we're good. Let's just move through this. All right. So at least do the restriction. So the sine of square root of 3 over 2, that is going to be negative, and that is going to be with the reference angle of pi over 6. All right. So now it has to be I know that it's negative though. It has to be in the third or the fourth quadrant. I know that the restrictions though of sine is the first and the fourth. So I can't use this angle, nor can I use this angle. I have to use my negative angle. And since my reference angle is pi over 6, and again, what I mean by that is that's the angle in the function here. Oh, jeez. Stop that. Why does that do that? And again, I am completely wrong. It's not pi over 6. That's sine, not cosine. So again, you can see that I'm starting. That is going to be for pi over 3. So the reference angle is pi over 3. So therefore, still we're going to be using our negative angle. So that was going to be a negative pi over 3. So now I have the cosine of negative pi over 3. So now I just need to evaluate the cosine of negative pi over 3. Well, again, we know that pi over 3, the cosine value is 1/2, right? But if it's negative, and that means it's going to be in the fourth quadrant. So we see this angle here, it's going to be in the fourth quadrant. So therefore, cosine we know is going to be positive. So therefore, that's going to equal a 1/2. So we can just say this angle value is equal to 1/2. All right. Cosine inverse of square root of 2 over 2. If you see that, you know that the x value, you can see that this is positive, so we know it's in the first quadrant. The cosine of what angle is equal to square root of 2 over 2, you can see that that is going to equal pi over 4. And then I have tangent of pi over 4, and that's equal to 1. Because the y coordinate over the x coordinate are obviously the same, so that's why it's equal to 1. Tan inverse of negative square root of 3, again, we just got to remember square root of 3 is going to be pi over 3. So therefore, if this is negative value, we know it has to be a value in the fourth quadrant, which is negative pi over 3. So now I have sine of negative pi over 3. And I think sine pi over 3, the y coordinate for pi over 3 is going to be is square root of 3 over 2. But since it's in the fourth quadrant, because again, we're doing a negative angle, it's going to be the fourth quadrant. That's going to be a negative square root of 3 over 2. All right, so now in this round, basically what we have now is the angle first, and then we're going to take the inverse of it. So in this one, we have sine of pi over 6. That's what I did for us. All right, so in this one, I have sine of pi over 6, which is in the first quadrant, which is awesome. So the sine of pi over 6 now is going to equal 1/2. So I can basically just rewrite this as cosine inverse of 1/2. And obviously that's positive in the first quadrant. You say, well, cosine of what is equal to 1/2? And then we know that's equal to pi over 3. And again, everything's positive, so we're in the first quadrant, so we're not worried about our restrictions. Negative 3 pi over 4, though, that gets a little tricky, right? Because when we look at this one, negative 3 pi over 4, that is in the third quadrant. And if we look at the tangent here, tangent is positive, though. So that's going to be the sine inverse of a positive 1, right? Because that coordinate point, remember, the reference angle in this case is pi over 4. So therefore, it's negative square root of 2 over 2, comma negative square root of 2 over 2 is the coordinate point. However, the tangent of that is going to equal 1. So now the sine inverse of 1 is, I got to go to which coordinate point here is when sine is going to equal 1. And you can see it's going to be that point right there. And therefore, that angle then is going to be pi halves. So again, when we're looking into doing the sine inverse, again, our answer eventually is going to be an angle. And again, let me just write this in there so people can see where I got positive 1. Okay. So tangent of pi over 3. Now, this is in the first quadrant. So there you go. So this is in the first quadrant, so we can just kind of focus on this. Now, these should undo each other, right? If it's in the first quadrant, if you're taking the tangent of pi over 3, which we know is pi over 3 is going to equal square root of 3. So then I have the tangent inverse of square root of 3. Well, obviously, the angle that gives us the square root of 3 here is just going to equal pi over 3. So basically, you can see when we're dealing with a composition of functions and they're all positive, we're just dealing with the first triangle. Like the function and its inverse undo each other, right? But remember, the restrictions matter. So when we look at like 5 pi over 4, when we graph 5 pi over 4, the cosine of 5 pi over 4, I should say, we just want to be careful. When it's in the first quadrant, a function and its inverse function undo each other. And you can just write in that angle. However, here, when we look at 5 pi over 4, we look at this point and we say, all right, this point on the unit circle is 5 pi over 4, so that's going to be a negative square root of 2 over 2, comma, negative square root of 2 over 2. So the cosine of this angle is equal to negative square root of 2 over 2. But we know that the inverse, the cosine inverse of negative square root of 2 over 2 is not 5 pi over 4 because look at where 5 pi over 4 is. It's outside of the restricted area, right? Negative 5 pi over 4 is in the third quadrant. Cosine is restricted between the first and the second. So the cosine inverse of negative square root of 2 over 2 is going to be this angle that's in the third quadrant, which is the same one over here, which is going to still have a negative square root of 2 over 2, but it's just going to have a positive y coordinate. And that angle is going to be, what are we doing with 3 pi over 4? Okay, so that's the angle in the second quadrant. They have the same coordinate point. The cosine's the same, but the green angle falls within the restriction of cosine, whereas the original blue angle, the 5 pi over 4, does not. And then now let's go and look at sine. So again, we have a sine inverse. So this is negative 5 pi over 6. So let's just go and sketch this where this is going to be at. So negative 5 pi over 6 is over here, right? It has a reference angle of pi over 6. So what I know about that then is this coordinate point on the unit circle is going to have the same reference angle as in the first quadrant, which is going to be square root of 3 over 2, comma 1/2. However, this point is in the third quadrant, so therefore both of these coordinates are going to be negative. So the sine of negative 5 pi over 6 is going to be equal to negative 1/2. Right? Now the sine inverse of negative 1/2, remember that the sine function is restricted between the first and the fourth quadrant. So obviously this angle does not work because that's outside of the restriction of our sine. So we think about, well, what angle then is going to give us negative 1/2 when we take the sine of it? And that's going to be the negative angle of negative pi over 6. And again, it has to use that same reference angle, right? I mean, it can't be pi over 3 or pi over 4. It's still going to be pi over 6, but it has to be negative. It can't be outside of this function. So therefore, that angle is going to be a negative pi over 6. All right, next one, tangent inverse of cosine of 2 pi over 3. So let's go ahead and graph 2 pi over 3. That's in the second quadrant. Cool. That coordinate point now on the unit circle, 2 pi over 3, that's going to have the same reference angle as pi over 3. So therefore, the cosine of that, oh, that's not going to work. I knew I was going to pick one of these problems. That one doesn't work. Let's do, let's change this to a sine. Okay, I knew I was going to have one. I hope I don't have another one of these. Yeah, okay. So the sine in this case is, so anyways, this point, sorry, I know I lost my train of thought. So I have cosine of 2 pi over 3. And that coordinate point here, let's see, the cosine is, that coordinate point is a negative 1/2 comma square root of 3 over 2. So the cosine, cosine of this is equal to a negative 1/2. So now I have a sine inverse of a negative 1/2. And now if I wanted to go ahead and find the sine inverse of negative 1/2, I basically got to see what is the angle, though, that meets that within the restriction, because sine is equal to, a negative 1/2, not for pi over 3, but for pi over 6, right? And actually, we have the angle, the answer right there. So that one's going to equal a negative pi over 6. And that is going to be it, because we didn't really cover inverse or trigonometric or reciprocal inverse functions. So actually, never mind. We can go ahead and work on these. These are, I forgot, we just didn't do the inverse of them. So let's go and work on this last set. All right. So last set, you can see we have these reciprocal functions. And again, just the reciprocal function is, if sine is y, then, cosecant is 1 over y. If tangent is y over x, cotangent is x over y. If cosine is x, then secant is 1 over x. So mix these up. All right, so let's go ahead and do the tangent inverse of negative 1. Tan inverse of negative 1, when is tangent negative? That's going to equal a negative pi over 4. So I have the cosecant of negative pi over 4. And again, you can kind of think of that as 1 over the sine of negative pi over 4. So the sine of negative pi over 4 is basically going to be 1 over negative square root of 2 over 2. And then when you multiply by the reciprocal, we know the answer is going to be negative, but hopefully you go ahead and get the answer and you see that it is, I'll just multiply it, square root of 2 over 2, 2 over square root of 2, and you rationalize the denominator and you get a negative square root of 2. That goes to 1, 2 over square root of 2. That's a negative, and then you rationalize. That gives a 2, and you get square root of 2. All right. Don't want to spend too much time on that, but hopefully if you're watching the video, you see this, and then you'll just be like, oh yeah, that's where we got the answer. All right, the next one is negative sine inverse of negative 1/2. So I'm thinking, when is sine inverse equal to negative 1/2? Well, we've done that example a couple times. That's actually negative pi over 6. So we'll do secant of negative pi over 6, which is really, again, the same thing as the cosine of negative pi over 6. And cosine for negative pi over 6, again, that's going to be in the fourth quadrant here. So therefore, the cosine is going to be positive. And for pi over 6, the reference angle, that's going to be square root of 3 over 2. So basically, it's 1 over the square root of 3 over 2. And then again, if you rationalize the denominator here, which again, just want to make sure that I remember the answer, which would be 2 square root of 3 over 2. Yep. Okay. So therefore, my answer for that one, when you simplify this, you're going to get 2 radical 3 over 3. So that answer is 2 radical 3 over 3. All right. Last but not least is cotangent and cosine of 0. So cosine of 0 is, or what angle gives me the cosine is equal to 0 between the first and the second quadrant? That's going to be pi halves. So the cotangent of pi halves is basically is asking us again for the x over the y angle of this angle right here. So again, this angle is 0, 1. So if I'm doing the x over the y, you can see that that is just going to give me 0. So that's where the answer comes in at 0. So there we go with the composition. It's really just the same thing from the first portion that we did. I mean, you're doing the exact same operations. The only thing is now we're involving, finding the values of the angles and then doing the inverse cosine. But again, if you can just think of these inverse trigonometric functions as just the undoing of them, right? You can see it's more apparent here. But again, just don't be caught in the trap, because the only reason why we have these inverse trigonometric functions is because we are taking into account the implied restrictions from the domain on their range. So if you don't apply those restrictions, you're not going to get to the right answers unless you get lucky and your angle's in the first quadrant. But outside of the first quadrant, you're going to be these restrictions are definitely going to come into play. So there we go. Now let's go ahead. I don't know why it's going up. Now let's go ahead and work on some similar answers, but ones that where we're not necessarily going to have points on the unit circle, but going back to our days of triangles.